No other probe has ever ventured as far into space as Voyager 1. Launched in 1977, the NASA veteran is racing through space at a speed of 61,000 kilometers per hour, moving further and further away from us. And yet, even though Voyager 1 is now more than 25 billion kilometers away from the Sun, we are still in contact with it. But how is this even possible? How can command be sent to a probe that has traveled such an enormous distance? And how long can we maintain communication? Be sure to stay tuned until the end if you want to know what tricks NASA uses to make us forget the endless vastness of the cosmos. Numbers can sometimes be deceiving. Interestingly, it was not Voyager 1 that first ventured into space on August 20th, 1977, but its identical sister probe, Voyager 2. The overall mission objective was to explore the outer planets of the solar system, which were still largely unexplored at the time. However, since the space pioneers were sent on different trajectories, and Voyager 1 took a faster route to Jupiter and Saturn, it overtook its twin and still lived up to its name. However, the ambitious project could never have been realized with pure rocket technology alone, as the probes would not have been able to reach the required speed. And so, it was that in the end, it was the planets themselves that generously came to the aid of the Voyager mission. At that time, a rare planetary constellation occurred in which Jupiter, Saturn, Uranus, and Neptune were aligned in a line, enabling the space probes to gain additional speed with the help of so-called swing-bys. And just so we're clear, according to calculations, this special planetary spectacle will not occur again until 2150. So NASA's timing was excellent, and Voyager 1 arrived at mighty Jupiter on March 5, 1979. There it took impressive images of its dense dynamic atmosphere and confirmed that even the king of planets has a faint ring system. In addition, it discovered active volcanoes on Jupiter's moon Io, causing sensation among experts. After all, this was the first time in history that active volcanism had been detected on a foreign celestial body. Voyager 1 then set course for Saturn, where it gathered important new insights into its famous rings and identified, among other things, small shepherd moons that are responsible for the stability and shape of the structures. It also turned out that Saturn's largest moon, Titan, has a dense atmosphere consisting of about 90% nitrogen, which is chemically somewhat reminiscent of the early Earth. After these groundbreaking discoveries, it was time for Voyager 1 to say goodbye to the planet and continue on to the edge of the heliosphere. Voyager 2, on the other hand, took a different route and headed for Uranus and Neptune. It's still the only space probe to have visited and explored these distant ice giants at close range, the advance into unknown worlds. But as we now know, Voyager 2 was also to continue its journey afterwards, following its sister into the unfathomable world of interstellar space. In a direct comparison of speed, however, Voyager 1 had and still has the edge. While Voyager 2 covers about 15 kilometers per second, Voyager 1 covers about 2 kilometers more in the same time. Despite all the differences in speed, both probes have now crossed a revolutionary boundary and passed the edge of the heliosphere. But what exactly does that mean? Well, basically the heliosphere is a huge bubble of charged particles that the sun constantly ejects into space. It is created by the so-called solar wind and acts as a natural shield that protects the interior of our home system from the high-energy cosmic radiation from interstellar space. However, it's not a rigid, uniformly shaped structure, but rather an irregular structure resulting from the movement of the sun through the Milky Way and the interstellar magnetic field. The exact shape and size of the heliosphere are therefore dynamic and change due to the solar activity, the pressure of the solar wind in the interstellar medium, and beyond the outer edge of the heliosphere known as a heliopause begins interstellar space where the influence of the solar wind ends. Voyager 1 and 2 gave us the first direct insights into this previously unexplored region and provided us with completely new findings. They detected a strong magnetic field emanating from the interstellar medium and a significant increase in cosmic radiation and high-energy particles originating from distant stars and supernovae. In addition, they were able to measure plasma oscillations for the first time, which were used to determine the density of the interstellar medium. The duo thus provided us with unique data from space far away from the stars and showed us what the cosmos outside our home system looks like. Or does it? Well, not quite. Although it is often said that the Voyager probes have left the solar system, this is not strictly true. They may have left a region dominated by solar wind behind them, but the solar system itself actually extends much further. Our host star therefore continues to exert gravitational control over distant structures such as the Oort cloud, a hypothetical spherical area consisting of billions of ice and rock fragments that serves as a reservoir for long-period comets. However, we will need to be patient before Voyager 1 reaches this region. According to estimates, it will reach the inner boundary of the Oort cloud in 300 years and will only have completely crossed it after about 30,000 years. How we stay in contact with Voyager 1. However, it's in the nature of things that the two Voyager probes have traveled a considerable distance over the past 50 years. To be more precise, Voyager 2 is now 21.0303 billion kilometers away from the Sun, and Voyager 1 is even further away at 25.13 billion kilometers. This naturally raises a question of how we can even communicate with the probes over such enormous distances. How is it possible to maintain contact over tens of billions of kilometers when the Wi-Fi signal in our homes breaks down as soon as we close a bedroom door? Well, the answer lies in a combination of the Deep Space Network and a lot of patience. Basically, the Deep Space Network is a global network of gigantic parabolic antennas located in California, Madrid, and Canberra. These antennas are designed to transmit and receive extremely weak radio signals over vast distances. And to do so, they have diameters of up to 70 m. In simple terms, you could say that the antennas are oversized radio satellite mirrors that collect and bundle tiny signals from space to make them measurable. Despite all this, communication with the Voyager probes is anything but easy. Although the signals are transmitted at the speed of light, they take around 21 and 18 hours respectively to reach Voyager 1 and 2. Consequently, it takes just as long for the probe's response to reach Earth. Added to this is the fact that the data rate is extremely low. Voyager 1 transmits only a few kilobits per second. A normal internet connection often transmits thousands to millions of times more data. Each transmission must therefore be planned extremely efficiently and carefully so that the valuable information actually reaches us. In addition, the signals are so weak that they first have to be filtered out of the noise of space on Earth using giant antennas and special amplifiers. This makes it all the more remarkable that NASA is still managing to maintain constant communication with the two probes. Well, provided everything goes according to plan, of course. However, the whole Voyager truth also includes the fact that the oldies have repeatedly made headlines with unexpected loss of contact. Particularly well known is the incident that occurred in October 2023. At that time, Voyager 1 suddenly began sending completely nonsensical data to Earth due to an error in the computer system. Fortunately, however, the experts managed to locate the error and get contact back on track. Just 1 year later, the main radio transmitter failed, and the engineers had to switch to a backup transmitter that had not been used for over 40 years. Voyager 2 also had similar problems. In July 2023, its antenna was misaligned due to a faulty command, causing it to point 2 degrees past Earth. However, thanks to an automatic reset, the probe was able to correct its alignment and re-establish contact. In April 2025, distorted signals were again received for a short time, presumably caused by a software error triggered by cosmic radiation. But NASA stated that this was only an anomaly with no long-term consequences. Okay, but what happens next? How long will we be able to maintain contact with Voyager 1 and 2? Well, it may sound a little surprising, but the answer to this question does not primarily depend on distance. Distance is not the limiting factor as long as the signals can still be received by the Deep Space Network's antennas. The decisive factor here is rather the power supply to the probes. The oldies are powered by radioisotope thermoelectric generators which generate electricity from the heat of radioactive plutonium. However, the corresponding output is continuously decreasing, which is why NASA has been putting the probes on a strict power dive for quite some time now. This means that more and more systems and instruments on board that are not essential for continued operation are gradually being shut down. In this way, the experts want to save as much energy as possible and extend the mission into the 2030s. But even when the day comes when the Voyagers no longer have power for radio communication and contact is lost, their journey will continue. This is simply because once a probe has been accelerated, it will remain in motion practically forever in the vacuum of space. And so it is that Voyager 1 and 2 could bear witness to the existence of humanity even in millions or even billions of years, no matter what may have become of us by then. And if you like, you can become a subscriber now. Simply click on the thumbs up and subscribe to never miss a new video from us again. See you soon.